In the beginning, there was nothing. No time. No space. No matter. Just an infinite void, empty and silent. The cosmos, as we know it, did not exist. No stars to shine, no galaxies to spin, no planets to orbit. Nothing. But, within this void, potential stirred. And then, in a single, unfathomable moment, out of this nothingness, everything was born. It was not a slow, gradual birth, but an instantaneous event that defies imagination. In an infinitesimally small fraction of time, the universe ignited into existence. This was the Big Bang, the most profound event in cosmic history. It wasn't just an explosion. It was the birth of time itself. The birth of space. The beginning of everything we know and everything we have yet to discover. This wasn't an ordinary explosion. There was no before. There was no surrounding space for it to explode into. The universe, our reality, began as an impossibly dense, infinitesimal point, smaller than an atom, but holding within it the entire fabric of existence. A cosmic singularity, beyond human comprehension, brimming with unfathomable energy and potential. It was a singularity waiting to unfold. And unfold it did. This wasn't an ordinary explosion. There was no before. There was no surrounding space for it to explode into. The universe, our reality, began as an impossibly dense, infinitesimal point, smaller than an atom, but holding within it the entire fabric of existence. A cosmic singularity, beyond human comprehension, brimming with unfathomable energy and potential. It was a singularity waiting to unfold. And unfold it did. In that immeasurable instant, 14 billion years ago, the universe began to expand. Faster than the speed of light, it stretched outward, carrying with it the very space in which it would later grow. Time and space were born together, their fates intertwined in a cosmic dance. What had once been a singular point was now stretching, growing, evolving, space itself expanding in every direction like a balloon inflating, though there was no outside for it to inflate into. The universe was creating itself. This initial expansion wasn't a peaceful one. It was a violent, searing storm of unimaginable heat and energy. A fireball of creation, so hot that even the most basic forms of matter couldn't exist. This was the primordial plasma, a chaotic, roiling sea of particles, quarks, protons, neutrons, and electrons, swirling together in a dense, white-hot soup. The universe was incredibly hot, far too hot for atoms to form. Particles collided with each other at breakneck speeds, their interactions dictating the future of the cosmos. Yet, in this chaos, there was the seed of something miraculous. As the universe expanded, it began to cool. And with that cooling, something extraordinary happened. Order started to emerge from the chaos. As the temperature dropped, the wild collisions between particles slowed down, and they began to form bonds. Quarks came together to form protons and neutrons, and soon, the first simple atoms began to take shape. The first element to form was hydrogen, simple, elegant, and abundant. Hydrogen would become the foundation stone of the universe. It was the building block from which stars, planets, and ultimately life itself would emerge. This basic element, born from the ashes of the Big Bang, was the raw material of everything we know. But the universe was far from quiet. The force of gravity, the great architect of the cosmos, began to assert itself. Hydrogen gas, now freely drifting in the cooling universe, began to clump together under the pull of gravity. These clouds of gas swirled and grew denser, gathering mass as gravity pulled them tighter and tighter. And then, something wondrous happened. The pressure within these clouds of hydrogen became so intense that their cores ignited. Nuclear fusion began. The hydrogen atoms fused together, creating helium and releasing vast amounts of energy. The first stars were born, flickering into existence like cosmic lanterns in the primordial darkness. These early stars were unlike anything we see today. They were giants, burning with an intensity and size that dwarfs our own sun. They lived fast and died young, shining brightly for a few million years before exhausting their fuel. These stars were the cosmic beacons of the newborn universe, illuminating it with their brilliance. But they were more than just lights in the sky. Inside their cores, these stars performed alchemy. Hydrogen fused into helium, and as the stars aged, they began fusing helium into heavier elements. Carbon, oxygen, silicon, all the building blocks of planets, of life, were forged in these stellar crucibles. But the most important element they created was iron, the very same iron that courses through our veins today. Yet, even these massive stars, with all their power and light, could not live forever. After burning through their fuel, they reached a point where their cores could no longer support the intense pressure. And in their final moments, they collapsed. But these deaths were not quiet. They were spectacular. When their fuel ran out, they died in spectacular fashion, supernovas, explosions so powerful they outshone entire galaxies. In their death throes, these stars seeded the universe with the elements necessary for life, scattering them far and wide. Every atom in your body, every particle that makes up the world around you, was once forged in the fiery heart of a dying star. We are, quite literally, made of stardust. As the universe aged, gravity wove a cosmic web of galaxies, vast, swirling islands of stars, gas, dust, and dark matter. Galaxies began to take shape, clumping together under the inexorable pull of gravity, spinning and colliding in a celestial ballet that continues to this day. But not all was serene. Galaxies crashed into one another, creating bursts of star formation and violent mergers. It was in one such galaxy, the Milky Way, that something remarkable was about to happen. About 4.6 billion years ago, in a quiet corner of the Milky Way, a small cloud of gas and dust began to collapse under its own gravity. At its center, the immense pressure ignited nuclear fusion. A star was born, our Sun. Around this newly ignited Sun, the leftover material began to coalesce. Dust and rock collided, forming planets, moons, and asteroids. One of these worlds would become very special. A small, rocky planet, third from the Sun, would become the cradle of life, Earth. Earth was a world forged from cosmic debris, yet unlike any other. As it cooled, it became a planet of storms and volcanoes, battered by the relentless forces of nature. But it was also a planet of oceans, where, deep beneath the waves, something extraordinary began. Life. It began with the simplest forms, tiny bacteria and single-celled organisms, thriving in the deep seas. Over billions of years, these humble creatures evolved into the diverse and complex life we see today. From the smallest microbes to the largest animals, life on Earth is a testament to the power of time and evolution. And then, against all odds, we emerged, humans. Born from the same stardust that created the universe, we became aware of our origins and our place within this vast cosmic story. We looked up at the stars and began to wonder. With our curiosity came exploration. We built telescopes to peer into the heavens, satellites to orbit our planet, and probes to venture into the unknown. We unlocked the mysteries of black holes, mapped the cosmic microwave background, and discovered the existence of dark matter and dark energy, forces that dominate the universe yet remain largely hidden from us. Despite all we've uncovered, the universe remains full of questions. What is dark matter, this invisible substance that holds galaxies together? What is dark energy, the mysterious force driving the universe's expansion? These questions push the boundaries of human knowledge and continue to inspire our search for answers. The universe is still evolving. Once bound by gravity, it is now accelerating apart. Galaxies are drifting farther and farther away from each other, propelled by dark energy. This expansion is a silent, unstoppable force that will eventually lead to a cold and lonely fate. In the distant future, billions of years from now, the universe will grow cold and dark as stars burn out and galaxies drift beyond reach. The lights of the cosmos will flicker out one by one, and the universe will be left in darkness, a slow, inevitable death known as the heat death. This is the ultimate fate of the universe. But this end is far from us. The universe is still young, and its story is far from over. As long as we exist, we are part of this grand cosmic tale. And as long as we ask questions, seek answers, and explore the cosmos, the universe's story continues. As we look to the future, one question remains: what will be humanity's role in this cosmic odyssey? Will we venture beyond our solar system? Will we unlock the deepest secrets of the universe, exploring new worlds and possibly encountering life beyond Earth? Or will we fade away, a fleeting moment in the vastness of time and space? The answer lies in our hands. We are the universe's children, born from stardust, and we hold the power to shape our destiny. The story of the universe is our story too. And as long as we continue to look up, to seek knowledge and wonder, the cosmic symphony will play on, an eternal testament to the beauty and complexity of existence.